right, in this lesson, we're going to be talking about functions and the inverse of functions and relations. Now, just as a review, remember a function is a relation in which every input has exactly one output. The inverse actually reverses a function. So here, if you look at the red line here, that's denoting a function. If you switch every point, every x and y value, so if you switch them around, what it does is it actually flips it over this dotted line right here, which is actually the line of y equals x. So the inverse of a function may not be a function. So here's an example of a relation. The domain is 1.2, 1.4, 1.6, and 1.9. Each of those goes somewhere. And this would be a function because every input has exactly one output. Now, when you write the inverse of that function, basically you switch the x's and the y's. In this case, it is the inverse, but it is not a function. You'll notice one has two different outputs. So in this question, it says, what is the inverse of relation S? Well, the inverse, it switches the x and the y value. So instead of 0, -1, you have -1, 0. Instead of 2, 0, you have 0, 2. Instead of 3, 2, you have 2, 3. And instead of 4, 3, you have 3, 4. Here's an example. Another example says, what are the graphs of S and its inverse? So first of all, let's write down the coordinates in relation S. So this is at 0, -1. This point is at 2, 0. This is at 3, 2. And this point is at 4, 3. So the inverse would switch your x's and y's. And we'll graph that in just a second. So -1, 0 is right here. You'll notice that basically reflects over this line. This is the line y equals x. Now we'll look at the point 0, 2. And this is reflecting over that red line. And 2, 3 is right here. Again, reflecting over. And 3, 4 is right here, again reflecting over. So this is the inverse right up here. What is the inverse of the relation described by y equals x squared minus 1? So this is going to be a function, and we want to find the inverse. So the process that you want to follow, which isn't real difficult, you just need to remember when you see inverse, switch the x and the y in the equation, and then solve for y, and that will give you the inverse. So let's switch the x and the y. So where there's a y, write an x. Where there's an x, write a y. And now solve for y. So we'll add 1 to both sides. So you have x plus 1 equals y squared. Now to get y by itself, y is getting squared. The opposite of squaring is taking the square root. So you take the square root of both sides. And remember, whenever we do that, we have to write plus or minus on the other side. So y equals plus or minus the square root of x plus 1. This is the inverse of this function right here. Next, it says, what are the graphs of y equals x squared minus 1 and its inverse y equals plus or minus the square root of x plus 1? So to graph the first one, y equals x squared minus 1, let's just make an xy chart. And we will plug in 2, 1, 0, minus 1, minus 2. We'll just substitute those in for x. So 2 squared is 4, 4 minus 1 is 3. 1 squared is 1, minus 1 is 0. 0 minus 1 is minus 1. -1, if we square that, it's a positive 1. Minus 1 is 0. -2 quantity squared is 4. 4 minus 1 is 3. So when we graph that, we have 2, 3, 1, 0, 0, -1, -1, 0, -2, 3. So this is a quadratic function, and the graph is a parabola. All right, let's graph the inverse and see what happens. So now we have a square root going on. When you have a square root, the minimum value inside of here can be 0. So in order to make a 0, x would have to equal -1. So if you plug in a -1, -1 plus 1 is 0, square root of 0 is 0. Now let's substitute in a 0. So we would have plus or minus 0 plus 1. So actually the output would be +1 and -1. So when you input 0, you can get two different answers, which tells me right there that this is not a function. Now I'm going to substitute in another number. I could plug in anything. I could plug in 1, but then I'd have the square root of 2, which is a decimal. So let's pick a number that will make a perfect square. So let's plug in 3. So 3 plus 1 is 4. So when you plug in 3, you would have plus or minus 4, which is +2 and -2. So when we substitute in 3, out comes 2 and out comes -2. Now let's look at how that is on the graph. So if we have -1, 0, that's right here, 0, 1, and 0, -1, 3, 2, and 3, -2. So this is a U shape, but it's sideways. And again, if we did the vertical line test and draw a vertical line through, it would hit 2 places. And so that is not a function, but that is the inverse. All right, next one says, consider the function f of x equals the square root of x minus 2. What are the domain and range of f? Well, the domain would be the x values that we could substitute in. Now, keep in mind that the minimum this can be here is 0. So x minus 2 has to be greater than or equal to 0. If you solve that, x has to be greater than or equal to 2. So that is our domain. X is greater than or equal to 2. The range, like we said, we have to have more than 0 here, and so the minimum this could be is 0, and the square root of 0 is 0. So the range would be y is greater than or equal to 0. Now here's a new symbol for us. It says f to the -1. Actually what that means is the inverse of f. So when you see f to the -1, that doesn't have anything to do with exponents. That's just a symbol that we use in math to mean the inverse of the function. So the function f of x equals the square root of x minus 2. If we're going to find the inverse, remember what I said the steps were? First, switch the x and the y. Well, remember f of x, that's like a y, so let's put a y there. All right, so to find the inverse, let's switch the x and the y. And now how do we solve for y? Well, we're going to have to square both sides. So x squared equals y minus 1. Now we solve for y. So y equals x squared plus 1. This is your inverse, which using the symbol, we could say that that is equal to this, the inverse function right here. So you just put the little -1 right there. So this is the inverse function. Let's do another. So here we have g of x is equal to 6 minus 4x. What are the domain and the range? Well, the domain could be anything. If we made an xy chart, we could plug anything for x. So we would say that it's all reals. And if we plug in anything, anything can come out. So the range is all reals. Now, we're going to find the inverse. So instead of g of x, let's write y equals 6 minus 4x. And to find the inverse, switch your x and the y. And solve for y. So you have x minus 6 equals -4y. And to get y by itself, you could divide every single term by -4, or you could just divide the whole side by -4. Either way is fine. So your inverse is this right here. So let's say that this is g inverse of x. So here's another example. For f of x equals 1 over x minus 1, what is each of the following? This means find the inverse. So the original function is f of x equals 1 over x minus 1. So instead of f of x, let's write y equals 1 over x minus 1. To find the inverse, we'll switch the x and the y. Now we have to solve this equation for y. Now, whenever our unknown that we're solving for is in the denominator, put the parentheses around that, multiply both sides by that. So on this side, everything cancels and you have 1. Here we have y minus 1 times x. There are a few ways you could do it. You could distribute, but actually we don't have to. So we want to get y by itself. So let's divide both sides by x. So now the x's cancel here. So you have y minus 1 equals 1 over x. And now we'll just add 1 to both sides. So y is equal to 1 over x plus 1. So this is your inverse. So this is just using the other notation. Now, the next problem, we have a function composition problem. And it says find f of inverse of 1. So what they're saying is find the value of the f function by putting in what the value of the inverse function is when x equals 1. So we start right here. Now the inverse function is 1 over x plus 1. So what we're going to do first is find out what this function is when x is equal to 1. So we're putting in a 1 right here. So wherever the x is, we're going to put this value in. So that's 1 plus 1, and you get 2. So the inverse function when x is equal to 1 is equal to 2. So now we're going to take that value and substitute that into the f function. The f function is f of x equals 1 over x minus 1, which would be 1. When we substitute in a 2, would be 1 over 2 minus 1, which is 1 over 1. So our final answer is 1. All right, in the next problem, again, we start right here. We're going to find the value of the f function when x is equal to 1. So f of 1 is 1 over, and instead of x minus 1, I'll put a 1 in, which is 1 over 0. This does not exist. Remember, we can't divide by 0, so at any point in the problem, if 0 is in the denominator, you would say this does not exist. And the party's over, we can't do any more. And that's because if you have a group of people, you can't divide them into groups of 0. So it's not even possible. All right, let's do one more. So if g of x is 4 over x plus 2, what is each of the following? So let's just call this y. And now to find the inverse, we're going to switch the x and the y. And then we solve. So I'll put parentheses here, multiply both sides by that. So you have y plus 2 times x equals 4. And then let's go ahead and divide both sides by x. So you have y plus 2 equals 4 over x. And to get y by itself, we will subtract 2 from both sides. So you end up with, for the inverse function, 4 over x minus 2. There's the inverse function. All right, and the next example says find g of inverse of 0. So we're going to first find the, from the inverse function, we're going to find the value of that when x is 0. So g inverse of 0, so it's going in right here for the x because that's the inverse function, would be 4 over 0 minus 2. Again, we ran into a 0 in the denominator, so this does not exist. Can't go any further. Let's try the next one. So here we're going to start with finding the value of the g function when x is 0. So the g function is the top function right here. So it would be 4 over 0 plus 2, which would be 4 over 2, and that is 2. So the g function's value when x is 0 is 2. Now we want to find the inverse of g's function, or g's value when the x is 2. So we're going to substitute 2 into the inverse function. So it'll be 4 over 2 minus 2. 4 over 2 is 2, and that value is 0. So to practice this, we have a worksheet that we're going to do, and I want to just work out a couple problems with you here real quick. So first of all, we're finding the inverse. So this is a y. We're going to call that y. F of x is like a y. So to find the inverse, we're going to switch the x and the y and solve for y. So now we'll add 2 to both sides. So you have x plus 2 equals negative 1/5 y. To solve for y, we have y times negative 1/5. We're going to multiply both sides by the reciprocal, which is a negative 5 over 1, or negative 5. So we'll do the same over here, multiply by a negative 5. So then we have a negative 5. We have to distribute x minus 10. And here this cancels, and we have just y. Here is your inverse right here. And that problem is done. Let's look at number 8 also. So f of x, when you see that, think y. Now to find the inverse, we'll switch those. And we solve for y. Y is inside a cubed root. So the opposite of cubing is taking the cube root is to cube. So we cube both sides. So you say x cubed equals y plus 1. And to get y by itself, we subtract 1. So y is equal to x cubed minus 1. And that is it for this lesson. Let me know if you have questions. Thanks for watching.